time is equal to 0 at this point. If we looked at the full parabola, this is at 9.2424 seconds, and this is negative 0.8832 seconds.
Wait, no.
All right, so
Oh, you talk about that line that says 0 is the 50.
yeah, this is would be 50 meters, and this is 0 meters if you want, or 40 meters.
But you just said when the ball had left your hand.
Yeah, this is time is equal to 0. This is time is equal to 0 at this point right here. The physical problem is this. That's the physical problem.
Okay.
But the math doesn't know there's a physical problem. The math only knows that here's a math problem. The math is trying to figure out, all right, at what point it sees a parabola, and it's trying to figure out the values that will make the parabola equal to 0. That's what the negative is it assumes that this parabola actually goes backwards in time. That from the problem's point of view, it could just as well have been launched from this point at whatever the correct velocity is. In terms of actually solving their problem, this is the one right here that we need. So let's put in for absolutely stunning visual effects. If it had been initially shot downwards, you'd also expect a positive and negative answer, except the magnitude of the negative would have been bigger. Because if you shot it initially downwards, it's going like this, but again, the math thinks that there's this whole other piece of it that doesn't exist physically. Now we know the time, we can solve for this. What equation do we need in order to solve for the horizontal displacement?
Third one.
Yeah, exact same one. So R equals 28.68 times 9.2424. Now throw in the rest part, plus 1/2 times 0 times 9.2424 squared. I'll save you some trouble, I'll do the second term for you. There we go. So somewhere around 250-ish. Yeah, it's not going like that.
265.07.
265.07. 265.07. And we can now correctly predict. And we'll do a lab at some point on projectile motion where we'll be launching it, and it comes out pretty darn accurately. Absolutely. And then some point later on the semester, I'll just be in the mood that we need to shoot things, and so we'll do a projectile motion one.
This is just I guess a random question. Would this be the projected amount of meters it would go if we were in a vacuum, since that we're ignoring air resistance?
Yes.
Okay.
Air resistance would slow it down, so let's see, air resistance it would be more like that with air resistance. It's not a parabola anymore, it's parabola-esque.
Can we still use the quadratic equation or formula? Sorry.
No.
No.
No, because acceleration is not constant, so we can't use any of those equations.
So as it falls, the air resistance would increase because its speed,
As the speed increases, the air resistance increases.
yeah, I think so. As it's falling, the speed's probably going to increase from what it was before. So would it, the air resistance increase as it's falling down, bringing it even further towards the wall as compared to the vacuums?
Yeah, the black line is my speculation, it would bring it in.
Okay.
And then you start getting into other things, because there's actually, when you get into it, air resistance has can be broken up into 3 different type factors. And so, you know, if I did a paper airplane versus a paper ball, it's possible for the paper airplane to go farther.
Yeah.
So, it gets way complicated way fast.
And depending on where you're at, if you're at sea level versus the Rockies, would the air resistance be different?
Air resistance would be different, and depends on how many significant figures, this number will start to change also at some point.
Yeah.
All right, Daniel?
I just want to talk about the simulation of this, will that actually predict where, like, you know, a cannon shooting a goal, like a cannonball will actually go using that?
You can, yeah, Joseph wants to say in a vacuum.
Yeah, in a vacuum.
In terms of the classroom, when we do our projectile motion experiment, it's not gonna be traveling so fast where resistance makes a huge difference. And so, we can shoot a ball across the room and have within 10% know where it's gonna hit. In terms of cannonballs, now we start getting into air resistance becomes more of a factor, and
Or simulate on the computer.
and then there's programs which actually take air resistance into account. The CBCC had a computer lab for conceptual physics class where they took air resistance into account. So I know there's a website out there where you can do that. I just can't remember what the website is. I suspect it's simple enough to find. All right, let's take a break, come back. We'll do another one of these problems, but harder. Just so you get a look at the simplest projectile motion versus the hardest projectile motion problem.
Would a bullet be highly affected by air resistance just because it's traveling so fast
Right.
and so small?
I would have thought so, but do you want to watch Mythbusters?
Yeah.
Did you see the one where they did the test on the bullet falling versus being shot?
Oh yeah, in terms of if it could kill someone?
No.
Oh.
In terms of, they did the experiment where they shot a bullet straight, and as soon as it leaves the barrel, another one falls. And they want to see which one hits
Okay.
first.
Got it.
In a vacuum, they should hit at the exact same time, assuming that this one indeed started to fall when this one came out of the barrel.
Gotcha.
And I was expecting air resistance would have a much more significant play a much more significant and be a very noticeable difference, but they hit within 1,000th of a second or something like that. They were really close to each other.
Wow.
So air resistance did not have as big an effect on the bullet as I would have thought.
And that's just because it's breaking the speed of sound and it's so small?
I know, because it was being shot with a rifle, and so the bullet was spinning, which reduced, I think, the overall drag.
Oh, okay.
Now, if they shot a musket ball, something that wasn't
Gotcha.
rifled, would that have had, I suspect that would have had, but again, I was surprised by this one.
Huh.
That and the elephant being scared by the mouse, those are the two that surprised me the most.
Yeah, that's a weird thing.
Yeah. Still not quite sure why.
Maybe the mouse used to be much larger and when the elephant was in a different stage of evolution or something. Maybe the mouse is related to the T-Rex.
That's possible. I mean, the closest cousin to the elephant is a creature that's about this big.
Yeah, maybe just over time, it's still just in it genetically.
It still seems strange.
Yeah. Especially considering how intelligent they are, or able to learn simple things an elephant is. But they can also be tricked pretty easily. You've heard about how they like thick heavy chains around like a tree trunk when the elephant's a kid, so it won't wander away.
Ah.
As it grows older, they put a stick with this like a piece of twine on it, and they still think it'll hurt their legs if they would try to get away from it.
It's amazing that. Oh, sorry. I'm pretty sure you have.
I know about it. Sure.
Tuesday, I think I talked to everyone about it. But You're good to go.
Get the final? Yeah.
Exactly, I haven't even go to see. When you're at the nice
Yes, we're good.
Okay, do you have a reason?
I do in my office, so.
They had it on.
Martina, you got a question?
On the lab.
Oh, yes.
Okay, I'll come.
Oh,
So we're gonna use the same one.
The question is, what were we actually testing? Right, but the question is, why are you using tape? So in the circumference versus diameter piece of the lab, and you said it to everybody, what were we actually testing? What did we plot? That was the second one, for the part A, what did you plot? Right, so we're looking, what is the relationship between circumference and diameter? If you use the formula, you're assuming what the relationship is already. If we were testing to see, is that actually valid? All right, so let's take a look at this problem. It looks similar to what we had before, except this time you don't have the angle. And again, there was one particular test where I did this and not thinking through how hard it would be. And then there's another test where I did this where it was like 1 of 4 parts of a problem, and I didn't see, but this is probably the hardest problem on the test, just so that I didn't want students to spend an hour trying to do it. This does require a little bit more knowledge of trig than what we've done so far. Not a significant amount, but. All right, but we can start out correctly. Oh, I apologize, there's no reason for this to be up here. So we can go through the exact same process. What are the initial horizontal and vertical velocities?
Horizontal is 50 meters.
Sorry?
Is vertical 50?
No, vertical is not 50. What did we do last time to figure out horizontal and vertical?
Sine and cosine of the angle times the hypotenuse, which was 50
Oh.
meters per second.
Good.
Yes.
So this is 50 meters per second times the cosine of theta, and this is 50 meters per second times the sine of theta. Last time we happened to know what theta is, but this is the math that we did to get it. I don't know what the final velocity is, doesn't really matter. How would you solve for time? What did we do last time to solve for time?
We use the third equation.
And we'll do so again. So we have two unknowns here. We have time and we have theta. So we'll need two equations. Fortunately, we have horizontal information, we have vertical information, and that will give us our two equations. So horizontally, using the third equation, we have 200 equals 50 cosine theta times time plus 1/2 times 0 times time squared. When we're plugging into these equations, please make sure that when you plug in the horizontal stuff into one equation, the vertical stuff into another equation, don't mix and match. The number of students who just always want acceleration to be 9.8 or negative 9.8, even when it takes place on another planet, some students still are so ingrained, acceleration is negative 9.8. One, it's an Earth value, and two, horizontally, it's 0. At this point, when a student mixes and matches, or they put initial velocities 50 meters per second, and then acceleration is 9.8 meters per second squared, that acceleration is vertical and that 50 meters per second is at an angle. They are not put into the same equation. So I've gotten to the point where I give very little partial credit to the student who does that. Vertical equation, we have negative 40 equals 50 sine of theta times time minus 4.9 t squared. Went ahead and skipped the step there. 1/2 times negative 9.8 is negative 4.9. That's where that comes from. I'm just going to rewrite the first equation, taking that out of it, so this becomes 200 is equal to 50 cosine of theta times time. All right, two equations, two unknowns. How do you solve it?
Equal to each other?
What am I setting equal to each other?
-1.
We cannot make up math here. Negative 40 and 200 are not equal to each other, so we cannot. Oh, I misunderstood, I apologize.
No, that row and that row, yes.
What do you mean to set them equal to each other?
So they're both read.
They're both- No, this first one's horizontal. Second one's, this is the horizontal equation. This one right here is the vertical equation. Pardon?
Is he talking about doing a composite function?
I'm not sure. That's what I was trying to figure out. You have an idea?
Equal to 0. Both equal to 0.
Set them both equal to 0?
Yeah.
All right, then set them equal to each other? All right, I'm gonna do that if I understood you correctly. Hold on. If I set them equal to 0, so I add 40 to both sides and subtract 200 from both sides. So I'd have 50 sine theta t minus 4.9 t squared plus 40 equals 50 cosine theta times time minus 200. What is wrong with this in terms of trying to solve?
The power change.
No, it's,
It's negative 200 instead of positive.
subtract 200 from both sides.
See.
There's two variables.
And how many equations now?
Well, one equation.
Yeah, one equation, two unknowns, really difficult to solve. So there's gotta be a different approach. Joseph?
If you just divide by 50 cosine of theta, when 200 equals 50 cosine of theta t, you get t equals 200 divided by 50 cosine theta, and you can then plug that in for t in the other equation.
So you solve for one of the variables in one equation and plug that into the other equation. If this were not well, theta is sort of mixed in with the cosine, so they're sort of, and the theta is here mixed in with sine, they're really tied closely together. There are simpler other problems which can be solved more easily, but something like this, where you got the two variables sort of intertwined like that, you really have to solve for one and plug into the other equation. So the equation I just crossed off is true, but it doesn't help us. So plugging our new value for t into the second equation, we get negative 40 equals 50 sine theta times 200 over 50 cosine theta minus 4.9 times 200 over 50 cosine theta squared. Now we have one equation, one unknown. It is not necessarily a simple thing to solve, but we do have one equation, one unknown. All right. What now?
You asked me if it went down or if it went down, is it something wrong?
What's the next step? All right, but because the theta is sort of tied in with the two different trig functions, it's a lot harder to do isolation like that.
Penta.
I mean, ultimately, yeah, but towards what end?
Parentheses, right?
Okay, but, all right, so you do what's in parentheses, but there's nothing, we can't simplify that anymore. Squaring, we can square that. All right, so negative 40 equals 50 sine theta times 200 over 50 cosine theta minus 4.9 times, that's be 40000 over 2500 cosine squared theta. All right, so there's the exponent.
Can you cross cancel the 50 cosine theta with, because you're multiplying them together, so it's over 1, so can you cross cancel those two? So it would be 200 over 1 and then 1 over 1, and then that would just be 200?
We can get rid of the 50s.
Okay.
We can't get rid of the trig function.
Okay, cool.
So the multiplication piece, before we could just multiply it out, sort of what I hear you suggesting. It is still helpful when multiplying fractions to simplify as best you can, so that 50 and that 50 cancel out. Those two zeros and those two zeros cancel out.
Wait.
Pardon?
Why'd you do that?
I'm trying to simplify it down so I don't have to deal with
No, the
numbers.
zeros.
That's, I have 40,000 divided by 2,500. You multiply top and bottom by 0.01, and you get 400 over 25. In essence, what I did. And that is equal to 16. Or we could have just done 200 divided by 50 first, and then gotten 4, and then squared it to get 16. So we are down to negative 40 is equal to 200 sine of theta divided by cosine of theta minus 4.9 times 16 divided by cosine squared theta.
Well, cosines cancel out.
No, they don't.
Oh, because it's squared.
If they were not squared, they still would not cancel out, but you could at least add the two fractions.
4.916.
All right, so do that multiplication, so we end up with, place for 1 here. All right, so negative 40 equals 200 sine of theta over cosine of theta minus, so 4.9 times 16. 78.4 over cosine squared theta. Now what?
Can you change the first part to 200 tangent?
Yep, yes you can. Sine divided by cosine is tangent. So negative 40 is equal to 200 times tangent of theta minus 78.4 over cosine squared theta. There's one technique of solving this in which doing that actually is crucial. There's another technique where you don't want to do that, so it depends on which way you go. Now we're sort of halfway in between both techniques, depending upon which way you want to go next.
Can you? 78.4%. Do that one?
What would you do with it?
No, do 210.
What would we do with that? I don't know what the angle is, so I can't simplify that anymore.
Wait, can you do,
All right,
can you do 78, what is it, 78.4 times cosine to the negative 2 theta?
you could, that's not really, I don't think it's gonna help us out.
Okay.
All right, so this gets into, this is why this is the hardest problem, is knowing what the trig identities are.
Wait, where is the 210? Oh, you can't continue.
Yeah, since I don't know what the angle is, I can't, I'm thinking the tangent of some unknown, I can't simplify this anymore.
Oh, okay, I was confused.
So let's see, some room here, all right. So we talked about cosine of theta being the adjacent over the hypotenuse. The sine of theta is the opposite over the hypotenuse. If I do sine divided by cosine of theta, that's going to be the opposite over the hypotenuse divided by the adjacent over the hypotenuse, which is the opposite over the adjacent, which is the tangent of theta. And that's what Sophie had suggested when we had sine over cosine, to just use tangent instead. I'm taking you through the simpler of the methods. So if you, at the end of it, you might go, man, no way I would have thought of that. Just recognize it's the simpler of the two techniques. The other one, that 1 over cosine of theta and 1 over sine of theta and 1 over tangent of theta. These are other trig identities, which we usually don't use. What's 1 over cosine?
Secant.
1 over sine
Cosecant.
and 1 over tangent?
Cotangent.
So this problem now reduces to negative 40 equals 200 tangent of theta minus 78.4 secant squared theta. This might not look simpler, but it actually is. The other thing that you need to know from trig, and I just wish to apologize to those students I had in the past where I gave this blindly, thinking, oh, sure, it's not a problem. Since we don't actually care about the time. All right. What is the basic trig identity? The one that relates sine and cosine together.
Sine squared plus cosine squared equals 1.
That's it. So sine squared of some angle plus cosine squared of that angle is equal to 1. That is a basic trig identity. It's basically Pythagorean theorem. If I divide everything by cosine squared theta, over here I have sine over cosine, so that's tangent squared. plus 1 is equal to secant squared of theta. Therefore, I just got an identity here for secant squared. So I have, looks like I'll probably need some room, so let me start over here. So negative 40 equals 200 tangent of theta minus 78.4 times tangent squared theta plus 1. The secant squared theta is equal to that. Now at this point, the more I write, the more likely I am to make a mistake. And so instead of writing out tan theta, I'm just going to do a shortcut. We'll come back, we'll make the substitution back later, but I don't feel like writing all that stuff out, so I'm going to use the letter, what have we not used very often?
Q.
Q. All right, so we'll do a Q is equal to tangent of theta. So I have negative 40 is equal to 200Q minus 78.4 Q squared minus 78.4. This is a quadratic equation. We can use the quadratic formula if we get it in the right format. This is now solvable. I know it's a quadratic equation because I have one variable here and it is squared. And for one of the terms. So getting everything over on that side over there, Brandon?
I was 78.4 written twice.
Distribute. So I get 78.4 Q squared minus 200Q plus 38.4 equals 0. The quadratic formula. You will get two answers. We cannot ignore either of the answers. What are the two values for Q?
Would it be negative 38.4 instead?
I brought everything over to that side, so when you add the 78.4 to negative 40, I get positive. But thanks for checking on that. Minus signs are the bane of my existence, especially in 152, so you know, I will not be shocked if I drop a minus sign somewhere in the direction, but